Hi guys, my name is Tafazo Sinzo and welcome to the Alphas Academy, where I'll be taking you through your AS and A level pure mathematics or your ZIMSEC pure mathematics A level. In this video, I'm going to talk about the introduction or the introductory topic to pure mathematics, which is all about polynomials and functions. So sit back, relax and enjoy this video. So first off, we'd like to start off at what polynomials are in particular and what are functions. But of course, we're going to look at functions as we progress, right? Very sorry for the quality or the way I've chosen to take my video. But the main purpose or the sole purpose of this video is to educate people, not to impress people via the quality of the video. So for those of you who might find this video helpful, feel free to share with your friends and family so that they can also benefit what you are benefiting right now. So let's get into business. A polynomial is best defined as an expression with an unknown term or terms as a plural whose powers are both positive and whole numbers as well. So these powers that we're talking about, we are saying that we have an example, maybe, or we've got examples which include x plus 3, right? We've got 2x squared plus 4. We've got x cubed plus 3. We've got x to the power of 4 plus 5. Now, a polynomial is simply a number, as we said. It's an expression rather that has got unknown terms. For example, unknown terms in x, right, which have got a power that is both positive and a whole number. As you can see now, the power for the expression that is written linear, it's a linear expression, that its name is 1, a positive 1. We look at the power of x on 2x squared plus 4, it's a positive 2, and that is called a quadratic expression. We've got the power of x cubed plus 3 being 3, which denotes the name cubic, right? We've got the power of x to the power of 4 plus 5, which is positive 4, therefore it is a quadratic expression. Now note that the unknown terms in these expressions are with regards, to what? To x, right? Hence x is the unknown term. Henceforth, the unknown term with the highest power is considered important, for that power is eventually called the order or degree. Many a times you might find that your expression will be x squared plus x plus 1, and then you're asked to denote or to name out the degree or the order of that polynomial. It is simply the highest power that is on one of the x's there. If it's x squared plus x, that means the highest power is what? Is 2, right? From squared is 2. The highest power is 2. Therefore, the order or degree is also 2. As much as x cubed minus 4x squared plus 5 is a polynomial of the third degree order. That's an illustration there. We're saying that the highest power of x there is what? Is 3. Therefore, it is a polynomial of the third degree. I.e., 4x to the power of 5 plus 3x to the power of 4 plus 2x squared plus 1 is a polynomial of what degree? It's a polynomial of what? Of the fifth degree. We've got the remainder theorem. Now, we want to illustrate what it is all about, but I'm not going to go straight into it. I'm going to try and turn around and use what you already know to your advantage so that you can be able to manipulate this data. So, we simply take a polynomial f of x to be 12, right? Therefore, we can say px or f of x is the same thing, function of x. We can say px is the same thing. So px is equal to 12 there. If we were to divide px by 5, it would look something like the following. I believe some of you looked at this when you were doing middle school. Some of you looked at this when you're doing primary level. For those who are doing ZIMSEC, for those who are doing Cambridge, it's obviously middle school or whatever grade you're using, if you are using another examination board. Now, so we have got that long division sign where 5 is the divider, 12 is the polynomial, and of course the answer that we get, we call it the quotient. right? So it's 5 into 12, we get a 2. But there's a remainder. Where do we put that remainder? Now, or how can we even find the remainder in the first place? So we say the quotient multiplied by the divider or the divisor is the same thing. You get 10 there. So you subtract 10 from the initial polynomial to get the remainder. What is left after you divide your 5 into your polynomial. So the key there is to denote that the divisor is denoted by the letter D, open bracket, X, close bracket. Quotient is denoted by QX. Remainder is denoted by K. With that being said, I would like to move on to the next page. Now on the next page, you notice me changing my camera position because I would like to convenience you, not to inconvenience you, isn't it? Alright, so where K is a constant, right? K is a constant. It is clear that if we multiply the quotient and the divisor, then you add the product to the remainder, we will get 12, right? We'll get a 12, as shown below. So you can say that Qx multiplied by dx plus k is equal to 12. K is obviously the remainder. 2 times 5, you get 10, plus 2, you get 12, which is equal to 12. Therefore, we have managed to prove what we are talking about. Now, someone can go further to analyzing this. For example, we want to see how we even get to that point of getting, for example, on the long division, that is explained now. We say 5 into 12, we get 2. Then that 2 is multiplied by 5 to get a 10. And then that 10 is subtracted from our polynomial 12 to get our remainder, which is easy peasy, lemon squeezy. We take our new coefficient to be Qx, our new divisor to be x minus a, and our new remainder to be b, right? It's not fixed. I'm just trying to illustrate a point, right? Our divisor, we've chosen it to be x minus a known number, a. So to get 10, our divisor was multiplied by our quotient. We are familiar with this now, isn't it? So it's now x minus a multiplied by the quotient. Thus, it's true to conclude that the divisor, if it is divided into the polynomial, we get our quotient qx, isn't it? But then this qx is multiplied by x minus a, just like how we multiplied 5 and 2, right? We get our answer there. And remember, we subtract that answer from what? From our polynomial x to get the remainder. So if you are saying that our remainder is 12, and then we do that whole process, it means that if px is divided by x minus a, which is not a factor, we will remain with a remainder. No remainder theorem. If we divide a certain number by something that is not its factor, we are bound to get a remainder, which is namely k. Hence, only that fact we equate x minus a to 0 in order to get the value of x, the normal way we dealt with factorization, etc. Right? So that you can substitute for that value in the polynomial px. I believe this will be more clear when you look at functions. But then if you look at px, you see with inside of that function px, there is that x, right? So we are saying that we want to substitute that x. How do we substitute that, or what number, how do we find that number that we substitute into or in place of that x? We simply say x minus a is equal to 0, as we did it at O level or IGC, whatever that you did. So you get x is equal to a. Therefore now finally we put a inside of x, and then we come back to principle where we say that for that given example there, we're saying that px is equal to what? X minus a multiplied by qx plus a constant. So wherever there's an x, we are now putting an a. Therefore pa is equal to a minus a multiplied by qa plus a constant. Therefore pa is equal to what? 0 multiplied by qa, which gives you 0 again plus a constant. Therefore pk is equal to k. Hence the remainder theorem has been explained. So now I move on to the next page where we are talking about something else. Now we are saying that by a similar argument, when px is divided by dx minus c, the remainder is what? polynomial of c over d. How did you get that? We simply equated dx minus c to 0. Therefore, dx is equal to c, x is equal to c over d. Therefore, wherever there was a c in our initial equation, px is equal to x minus a multiplied by qx plus a constant. We are now putting c over d. Given that polynomial px is equal to 4x cubed minus 8x squared plus 12x plus 7. The equation now comes as 4x cubed minus 8x squared plus 12x plus 7 divided by x minus 1. How do you get your answer there? It is clear that x minus 1 is our divisor, isn't it? So it's our divisor. I'm very sorry for how those notes were written there. It's our divisor. So we simply equate it to what? To 0. Therefore, x is now equal to 0. Function of 1 or p1 is our remainder. How do we find our p1? We say p1 is equal to 4, open bracket, 1, 1 close bracket cubed minus 8 open bracket 1 close bracket squared plus 12 open bracket 1 close bracket plus 7. So you get 4 minus 8 plus 12 plus 7, you get 15. So now you are being asked, you're not necessarily being asked to divide that, but you're being asked of the remainder. What is the remainder if you divide 4x cubed minus 8x squared plus 12x plus 7 by x minus 1, and then that's how you calculate it. You end up getting a 15. If you want to prove yourself, there is this other method which obviously guarantees you a lot of marks, by the way. So we can go over it. Now we're saying that x minus 1 divided into 4x cubed minus 8x squared plus 12x plus 7. Right. So we're saying that the first thing that we do is that we look at the degrees of the defined polynomials, right? The expressions that we have. We've got x plus x minus 1 is our first expression, and 4x cubed minus 8x squared plus 12x plus 7 is our second expression. So as we are looking at that, we are saying that the highest powers of x in either expression determine how these things are divided. For example, you can divide a polynomial that has got a greater degree or order than its numerator, right? We're taking a situation whereby for the fraction, right? Some sort of something like that. So the denominator should always have a degree or order that is less than the degree or order of the numerator, or the number that is to be divided into. For example, in this case, 4x cubed minus 8x squared plus 12x plus 7. You see now 4x cubed, that means it has got a degree or order of 3, which is obviously greater than x minus 1's degree or order. So you deal with these degrees only. You deal with the number with the highest degree. For example, if you say x minus 1 into 4x cubed, right? Forget about the minus 1. Look at the x. X into 4x cubed. That's your first and primary step. You say x into 4x cubed, and then you get 4x squared. You see now above the division line, I've written 4x squared is the first number that I've written in my working. So that 4x squared is the number that you multiply by the divisor, which is x minus 1, to get what? To get 4x cubed minus 4x squared. Now, if you look a little bit to your right, you see I've labeled that product x, right? I've labeled that product x, right? And then what do we do to x? We subtract it from our initial polynomial or our quotient. Not our quotient, but our polynomial itself. So we subtract it from 4x cubed minus 4x squared plus 12x plus 7. Right. So a 4x squared, we are saying that 4x squared is multiplied with x minus 1 to get 4x cubed minus 4x squared. We separate it from 4x cubed minus 8x squared plus 12x plus 7. We are getting minus 4x squared plus 12x plus 7. And I've labeled that qx, right? Polynomial x, but now it has got a q instead of a p. So we do the same thing. X into negative 4x squared, you get negative 4x. You multiply that negative 4x by what? The divisor, to get y, right? To get what? Negative 4x squared plus 4x, which I have labeled y. You separate that y from qx to get what? To get 8x plus 7. And I have labeled that as kx is 8x plus 7. When you reach this point, you are simply saying x into 8x and you get 8, positive 8 to be precise, multiplied by x minus 1, you get 8x minus 8. You subtract that from that polynomial Rx to get 15 is our remainder. So you can go over this, familiarize yourself with this, make sure that you become friends with this narration. For long division to occur, the x in the divisor is divided into the term 4x cubed to get part quotient a, which is 4x squared. I've labeled that part quotient a if you look closely in this picture, right? The 4x squared is multiplied by the whole divisor to get x, which I've shown there, right? X is separated from px to get a new polynomial qx. Then the x in the same divisor is divided into the term with the highest power for the polynomial qx to get what? To get b, which is what? Negative 4x. If you get negative 4x, you multiplied by x minus 1, and you get what? You get Rx, I believe. And then if you get Rx, you simply need to undergo the same procedure and then make sure that you come up with the same remainder. Now, we can just go back to where we started when we say that 5 into 7, that's another example, and you get 1. Multiply that by 5 to get negative 5. 7 minus 5, you get a remainder of 2. That's one way of doing that. And then you say well, the final answer now is equal to 1, which is the quotient, plus the remainder 2, right? But when you write the remainder now, you don't forget to also showcase the divisor. So it's 1 plus the remainder 2 all over the divisor 5, and then you are done with that page. Let me move on to the next page. On this page, we are saying that we are looking at another situation, or we can say that for the above in Fig 1.0, which is the previous one, which was saying that 4x squared minus 4x plus 8 plus 15 over x minus 1 is our final answer there. As we illustrated from saying 5 into 7 is equal to 1. That's 1 multiplied by 5, and so forth. You can find the final answer from there. To prove that your long division is correct, substitute for values of x into the polynomial. The resultant will be equal to the remainder, which is what you did initially. I believe you still remember that. The factor theorem, as drawn from the remainder theorem, if px is divided by x minus a, which is not a factor, a remainder k is observed. But then what if we divide with a divisor that is a factor? We obviously get no remainder. Therefore, PA in this case will give you a 0. Now, to factorize means to fish out factors of something, isn't it? So when I ask to factorize x squared plus 6x, how do we do it? We simply say, what are the factors of the last number that does not contain in what? An unknown term, which is in this case 8. The factors of 8 include plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now your job now is to substitute those values into your polynomial. You start with plus 1, right? You start with plus 2. It's now a trial and error situation, right? So to make this a bit simple for us, we need to remember that these factors that we have shown there, they are simply more of like we are saying x is equal to plus or minus 1, x is equal to plus or minus 2, x is equal to plus or minus 4, x is equal to plus or minus 8. So that's basically what we are talking about there. So when you're saying that x is equal to 1 is our factor, the root factor will be that 1 from the right hand side is taken to the left hand side to become negative 1. Therefore, it's now x minus 1 is equal to 0 as your factor. But in this case now we are saying that you can start with plus or minus 2, and then you say p2, we say 2 squared plus 6 multiplied by 2 plus 8, you get a 24, which is not equal to 0. Therefore, x is equal to 2 is not a factor of that polynomial. We try minus 2. We say p minus 2, and then you see that you get what? You get 0 there. So it means x is equal to minus 2 is our factor, right? So how do we rewrite that factor in its correct form? We say x plus 2 is equal to 0. Therefore, x plus 2 is a factor. To find the other factors, you can now use long division. X plus 2 into x squared plus 6x plus 8. I move on to the next page. On this page now, we are continuing with our quest to factorize that using this method we've just learned. Cool, isn't it? So let's hang on and continue with what we are doing right now. I believe this is fun. For me, it's fun. I love mathematics, and I believe you also love mathematics. You're also going to be good at it. So x plus 2 is divided into x squared plus 6x plus 8. The same procedure, x into x squared, you get x. X times x plus 2, which is the divisor, you get what? X squared plus 2x. We subtract that from what? From x squared plus 6x plus 8, which is our what? Our polynomial, to get 4x plus 8, which becomes now our new polynomial. X into 4x, you get 4. You say 4 multiplied by x plus 2, you get 4x plus 8. What do you get? You get 4x plus 8, okay? So you subtract 4x plus 8 from 4x plus 8, you get a 0 there. It means you have done the right thing. So that's how you go about that. That's how you go about that. An example now, I've got x cubed minus 3x squared plus 7x minus 10. You're asked to factorize that. You go through the same procedure, look for a factor. I believe you have your factor to be x minus 2, right? After that vigorous process of going through it, and then you finally end up having something that looks like that. Say x minus 2 into x cubed minus 3x squared plus 7x minus 10. So you say x into x cubed, you get x squared. That's the first number that I wrote above the line. That x squared multiplied by the divisor, I get x cubed minus 2x squared. You subtract x cubed minus 2x squared from the polynomial, you get negative x squared plus 7x minus 10. You do the same thing. Now you are getting negative x. You multiply by the divisor, you get negative x squared plus 2x. You subtract again from the new quotient, and you get 5x minus 10. You go through the same process again. It's a repetitive process. Once you get it, you are now in the game. So we get that, and then we've managed to factorize that. Of course, we express that as x minus 2 multiplied by x squared minus x plus 5. You are now home and dry. Find the values of a and b in the polynomials. In the polynomial, gx is equal to 2x squared plus ax, 2x cubed plus ax squared plus bx minus 12, given that the roots are 2 and minus 2. Right, in your answer now, you're saying g2, right? You are substituting the roots. The roots are simply, how can I put this? Now, the way you can understand roots is that a root is simply the value of x, right? It's simply the value of x. So when your roots are x is equal to 2 and x is equal to minus 2. So you are substituting for values of x is equal to 2 and x is equal to minus 2. For the first part, if you use x is equal to 2, you get 0. Since they are said to be roots, if they are roots now, it means they are factors. If they are factors, it means the remainder is 0. So if you substitute those factors into your polynomial, you should get a remainder of 0. Therefore, you've got 0 is equal to 16 plus 4a plus 2b minus 12. Hence, x minus 2 is a factor or a root, as it has been said earlier on. So minus, you can rearrange that to get minus 4 is equal to 4a plus 2b. Therefore, you can reduce that. You divide everything by 2 from that equation to get minus 2 is equal to 2a plus b as your first equation. Now you are substituting for negative 2, p negative 2. You put that into your polynomial, and then you get 0 is equal to negative 16 plus 4a minus 3 minus is it 2b? Yes, it's minus 2b minus 12. You make something out of that. So you get 28 is equal to 4a minus 2b. Therefore, 14 is equal to 2a minus b as your equation 2. I believe you have looked at simultaneous equations back when you were doing IGCE or O-level ZIMSEC syllabus. So with your knowledge of simultaneous equations, I believe you get your A being 3. Test yourself out. It's up to you to find the correct thing. Prove me wrong. A is equal to 3, b is equal to minus 8. Therefore, now we are putting those values in our original polynomial. Now we want to find the other roots. We want to find the other roots. We've got only 2 roots, but this one is a polynomial of the 3rd degree. It means it has got 3 roots. So we will use those 2 roots to find the other root. How do we do that? We say x plus 2 into our polynomial, we get 2x squared minus x minus 6. I believe you are now familiar with the way of dividing polynomials, isn't it? So with that being said, we'll get to a point where we see that the remainder is 0, therefore we've done the correct thing. We take our answer now, the new polynomial, which is 2x squared minus x minus 6, which of course is our quotient. We will divide it again by the other root, right? So x minus 2 into that quotient, you get 2x plus 3. So we use 2x plus 3 as our 3rd root. That procedure is highly simple at many levels. I believe you can get it from just listening to how I looked at it. So now I move to the other part of the page where I'm saying that therefore 2x squared plus 3x squared minus 8 minus 12 is equal to x plus 2 multiplied by x minus 2 multiplied by 2x plus 3. Long division is done until the order of the coefficient is equal to the order of the divisor. Right? In fact, the order should not be equal. It should arrive to a point whereby the divisor has got a greater order than the remainder. You get the sense? The divisor should have got a greater order than the quotient or the remainder. That's when we stop long division. So if I'm saying x minus 1 into x, we can still divide that. But you can't say x minus 1 into 2. You can't do that. You can't say x squared plus 2 into x. You can't do that. There's a question there. Find a for which x minus 2 is a factor of 3x squared plus ax squared. So it's 3x cubed. My apologies. 3x cubed plus ax squared plus x minus 2. Therefore, f2, right, that's the factor, is equal to 3, 2 to the power of 3 plus a multiplied by 2 to the power of 2 plus 2 minus 2, you get 24 plus 4a plus 0, you get to 0. Therefore, we've got negative 24 is equal to 4a. Therefore, a is equal to negative 6. Show that for the value of a, the equation has no real root. That's part 2. We're asked to find a. We did that with much simplicity. But now we are asked to show that for that value of a, the equation has no real root. How do you do that? You first of all do long division to find a quadratic expression, that which we can deal with. Now we can only determine whether a curve or an expression has no real root if you are dealing with a quadratic expression specifically. In other cases, maybe a line, but in these cases, we really recommend that you look at it only from a quadratic expression point of view. So if we've got x minus 2 dividing into 3x squared minus 6x, which is the new gotten value of a, plus x minus 2, you find that the remainder is 0. Therefore, you have done correct calculations. And therefore, if what the quotient being 3x squared plus 1. So that 3x squared plus 1, which is the same as saying, remember when you looked at quadratics, you were told that every quadratic expression conforms to that format, which says that ax squared plus bx plus c. So in this case now we're saying that 3x squared plus 1 is very identical to ax squared plus bx plus c. In what sense? Where a is equal to 3, b is equal to 0, and c is equal to 1. To acquire the types of roots present, we use the discriminant. But what is the discriminant? The discriminant is gotten from the quadratic formula, right? The quadratic formula says that x is equal to minus b plus or minus root of b squared minus 4ac all over 2a. Now the discriminant therefore is equal to whatever is inside the square root sign. In this case, or in every case, is b squared minus 4ac. Now, when b squared minus 4ac is greater than 0, it means that the square root of b squared minus 4ac is a number that is obviously above 0, which is a real number. So it means to say that b squared minus 4ac, when b squared minus 4ac is greater than 0, two real and distinct roots are observed. E.g., when b squared minus 4ac is equal to 100, you can say that x is equal to minus b all over 2a plus or minus root of 100 all over 2a. 2a, therefore x is equal to minus b plus or minus 10 over 2a. That 10 that is the number that we're talking about. So the two real and distinct roots are what? Are 10 and minus 10. From finding the square root of 100, we find 10, we find plus or minus 10. So there are two real and distinct roots, right? We can represent that on a graph, and it would look like how it looks like on the next page where we are looking at the graph itself. It would look like that. It would be for example, if it was cup shaped, right? Actually it is cup shaped because it's we're looking at 3x squared plus 1. The coefficient of the x squared is positive 3, right? The fact that 3 is positive, it makes a curve that is u-shaped. But if 3 was negative, we're going to get a graph that is dome shaped. So that's where we got this, and then we're saying that our graph would look like that. All right, I've linked two things here, but that's a new thing that we've just learned. Anyways, it will look like that, and then we've got those two distinct roots as shown there. Situation 2, when b squared minus 4ac is equal to 0, one real and repeated root is observed. Right, so we've got how we can illustrate that on that graph, and then that's one of the basics that we need to know. When b squared minus 4ac is less than 0, we produce imaginary or complex roots. Do you know that if you say root of negative 1, you get an error on your calculator, right? On your calculator it would be an error, but mathematically you would have gotten a complex root. So a complex root is gotten whenever I say b squared minus 4 ac is less than 0. So the graph will look like that, where it's not intersecting with the x-axis. Therefore, it has got imaginary or complex roots. Back to the equation where a is equal to 3, b is equal to 0, c is equal to 1. You can say b squared minus 4ac is it greater? Is it equal? Is it less than? Right? So let me go back to the previous page. All right, that's fine. Okay, so is it greater than? Is it less than? Right? So here you see that we get 0 squared minus 4 times 3 times 1, you get minus 12 is less than 0. So b squared minus 4ac is less than 0, meaning the expression has no real roots. It has got imaginary roots. It is above or below the x-axis. I believe this is simple to understand. A parabola. Now, the turning points are inevitable on a quadratic function, right? They are either minimum or maximum depending on the coefficient of x squared, which I have just talked about, but I'm going to go in depth. If a in ax squared is equal to plus 1, the graph looks like that. The graph is cup shaped. It's not fixed as in the coordinates, but it is cup shaped. That's the point, and it has got a minimum point. If a in ax squared is equal to minus 1, the graph has got a maximum turning point as shown on the graph below. We have got proof, don't we? Plot graphs of x is equal to x squared and of y is equal to x squared and y is equal to negative x squared. If you can redraw the diagrams, unfortunately I've just taken my student's notebook, and then I've taken pictures from the notebook. So the way these diagrams were drawn, these final diagrams, they should be curves, not lines. But then I believe maybe it was out of lack of technical hands, right? The student lacks technical hands. But as for you, you should construct a smooth curve, right? Either that is got a minimum or a maximum turning point for those given situations. Thank you very much for attending today's lesson. I hope to keep on posting these videos on a weekly basis so that you keep on being informed about what you are going to encounter in your journey in pure mathematics, A level or AS and A level. Please don't forget to tell a friend that there is this channel called the Alphas Academy, and you have got myself. I'll be taking you for A level, right? Maybe that's all for this video. See you next time. Make sure you subscribe to our channel. Make sure you put a like so that I'll keep on posting these videos. If you've got queries, if you've got questions, feel free to to comment them in the comment section below. You tell me the problems you're facing. Maybe I will inbox you, or maybe we'll converse on a WhatsApp platform. We will have maybe a short seminar there, right? Thank you very much once again for attending today's lesson. I believe this marks the end of our lesson.